In this series of examples, I'm going to show you how to solve differential equations. Here there are two methods that are relevant. One is by direct substitution and one is by separating the variables. Notice that in this particular differential equation, there is only one y, while the rest of the variables are all x. If you look at the differential equations in A, B, and C, the variables are all mixed up, x and y are all over the place. So for part D, this will be solved by direct integration, and part A, B, and C will be solved by separating the variables. So let me attempt part D first. So to solve for the differential equation in part D, all I need to do is to put all the terms on the right hand side. So if the differentiated form of y looks like this, then all I need to do is to integrate the right hand side to solve for y. So integrating x squared is x cubed over 3, integrating 1 is x. So this is the answer. To solve for A, I'm going to be separating the variables. So if you see the variables, you have a variable y here, variable y here. So I'm going to put them all on one side, maybe the left hand side. So if I were to move y over, I have 1 over y, and dy remains. Now I'm going to put all the variable x on the right hand side. So 2x remains on the right hand side, and dx move over on the right hand side. So now I just have to integrate both sides. So integrate 1 over y with respect to y is ln y. Integrating 2x with respect to x is x squared plus c. So this is the answer. Now we can also make y the subject and get rid of this ln. If you can recall, ln of a equals to b implies that a equals to e to the power of b. So applying this here, if I were to move the ln over to the right hand side, it becomes an exponential function. So bringing the ln over to the right hand side, it becomes an exponential function. Now, again, we have indices law here in play, so I can remind you first that a to the power of m plus n is actually a to the power of m times a to the power of n. So addition in the indices become a product. So let me break this up into a product. So what we have here is exponential function of a constant. Since this is a constant itself, so this e to the power of c is just another big constant, so I'm going to call this a. So that's the answer. To solve the differential equation in part B, I'm going to separate the variables as well. So before I start, let me remind you of the indices law. If I have addition in the indices, I can break into a product. If I have subtraction in the indices, I can break into a division. So if I were to rewrite this, I have a division here and a product here. So I have a e to the power of t divided by e to the power of y times e to the power of 2. So now I'm going to separate the variables by putting all the y's on the left hand side. So dy remains on the left hand side. ey can be multiplied up to the left hand side. And on the right hand side, I'm going to put all the t's. So I have et remaining here. e2 exponential of 2 remains here. And dt can move up. So now I'm going to integrate both sides. So integrating exponential of y with respect to y is just exponential y. Now e squared is a constant. Integrating exponential of t with respect to t is just itself, exponential t, and plus c. So let me put this back together. The indices can be added together. So I have e 2 plus t or t plus 2. So this is the answer. Alternatively, you can make y the subject by getting rid of e. So recall, if you have e to the power of a equals to b, you can make a the subject by taking logarithmic on each side. So ln the left and ln the right. So this ln and e, they offset each other. So I have a ln b. So I just have to ln both sides, and I will have make a the subject. I'll do that here. I'm going to ln this side and have y, and I'm going to ln this side. So this is my answer. To solve the differential equation in part C, I'm going to separate the variables. So I'm going to move all the variables in y on the left hand side. So dy is already on the left hand side. So move this y over, become 1 over y. And next I'm going to move all the variables in x on the right hand side. So x is already on the right hand side. Move 1 plus x squared over, become a denominator. Dx move over. So now I just have to integrate both sides. So integrate 1 over y is just ln y. Integrating x over 1 plus x squared, you will have to do integration by substitution. So differentiating the denominator, I get 2x, so I need a 2. Alternatively, you can try using the substitution method where u equals to the denominator. So quickly, I have integrating this by substitution, I would have ln of the denominator. So this is my answer. Alternatively, if you want to make y the subject of the formula, again recall, if you have ln a equals to b, then to make a the subject, ln to the right hand side become exponential function. So let's apply it here. So y equals to e to the power of half ln 1 plus x squared plus c. Now I'm going to use the law of indices to break this up, meaning if you have a to the power of m plus n, I can rewrite it as a product. So I have e half ln 1 plus x squared times e to the power of c. So I can rewrite e to the power of c as another constant, a, because exponential of a constant is another constant. Next, if you were to look at this part, I got to bring in another logarithmic rule. It says that if I have ln a to the power of b, actually this b becomes a constant factor. So this b, the power of a, becomes b, a constant factor. So if I apply it to this half, half can become a power. Remember I said that exponential of a constant becomes another constant. So back to this. Now when you have e and ln coming together, they offset each other and you just have a. So we have beat and ln coming together, they offset each other. So you just have 1 plus x squared power half. And I just bring a to the front, so this is my answer.